So let's take a look at a pretty basic triple integral in rectangular coordinates. We're given this region we're going to integrate over. We've got some curves that are in the xy plane. We should graph those and then consider what z is doing. So I guess we'll do it this way. We'll draw an x, y, z axis here. And let's look at this one, y equals square root of x. That's just a graph like that, y equals square root of x in the xy plane. We know x equals 1 is a vertical line like this. Y equals 0 means that we're staying on the x-axis. So this is the area we're integrating over. And then the actual height of this solid, whatever it's going to be, is determined by this function. Now, you could tell, for example, if we plugged in 0, 0 would be exactly at 1. And if we plugged in other points around here, we would get points maybe that were a little bit higher or something. So you end up getting is like a little section of a plane floating up above this region. And we're only interested in the volume of the object that has this plane as its top and this bottom of this. I'll shade it in green. The bottom is just this little curved type of region. Okay, so we can actually quickly write these limits of integration on here. We need to commit to an order. So we're going to say we're going to do dz, dy, dx. And that's easy because z simply goes from 0 to the plane, 1 plus x plus y. Y is varying between 0 and square root of x, and this is all happening as x goes from 0 to 1. So that's the integral that we're going to work on. It's just a computation from here on in. Let's go do that. So let's see if I can remember it. From 0 to 1, from 0 to rad x, from 0 to 1 plus x plus y, 6xy, dz, dy, dx. Let's do one integral at a time. With respect to z, we would get 6xy and z, because this has no z in it, so the antiderivative is just that times the constant z. Evaluated from 0 to 1 plus x plus y. Plugging in 0 is just going to cancel everything. We plug in the other one, we get 6xy times 1 plus x plus y. I'm going to take a minute to distribute that. We'll get 6xy plus 6x squared y plus 6xy squared. And now it's time for the next integral. So that's going to go from 0 to rad x, and dy is the variable. So integral, let's use a different color. So from 0 to rad x dy. So y is the variable. So here we go. Antiderivative here with respect to y. 3xy squared would do it. If you take the derivative, you'll get back this 6xy. Plus the next one, if y is the variable, 3x squared y squared would do it. And then lastly, for this one, we'll have, looks like we need a 2xy cubed. In each case, take the derivative to check it and make sure it looks reasonable. We've got to evaluate this from 0 to rad x. Again, plugging in 0 is just going to, for all the y's, will cancel everything, but the rad x won't. Plug it into the first one, I get 3x times rad x squared. I'll write it out, why not? This will end up being 3x squared times rad x squared. And oops, that's pretty sloppy. Shouldn't have bothered. Let's just leave it. Rad x squared. And then lastly, you'll get 2x rad x cubed. All right, plugging in 0 said we'll cancel everything. So this here, we need to sort of combine some, like, we'll make things look a little simpler. So rad x squared is just x, and then times x is going to give you 3x squared. The next term, you have 3x squared times x, so you get 3x cubed. And in the last case, this is x to the 1. This is really x to the 3/2 power. Don't forget it's power over root. So plus the 1 from over here gives you 1 plus 3/2 or 5/2. So it becomes 2x to the 5/2. Integral dx from 0 to 1. At least we get to plug in 1 when it's all done. So our antiderivatives for our first one is just simply x cubed. for the next one, 3/4 x to the fourth. Just think about it. 4 comes down in front. 4 times 3/4 will give you that 3 x to the third. And then plus here, this needs to be x to the 7/2. And sometimes this could be a little bit confusing. So just bring that 2 down. And remember, when the 7/2 comes down in front, it needs to get canceled. So there must have been a times 2 7s here to get rid of that. 7/2 that's going to come down. Let's just do a little bit more work here. So we get x cubed, 3/4 x to the fourth, and that's really 4/7 x to the 7/2, evaluated from 0 to 1. And really 0 is the easiest number to plug in, so there will be nothing to subtract here. When we plug in 1, 1's like the second easiest number. You'll get 1 plus 3/4 plus 4/7. Here comes the hardest part of the problem. You have to add fractions. Oh, so what's your common denominator going to be? I think 28. So we'll have 28 over 28 plus 4 times 7 is 28. So this would have to be 28. So 3 times 7 is 21. And then lastly, 7 times 4 is 28. And there's a 4 on top there. So this will be 28 here, and this will be 16. So now we just got to add those numerators, 28 plus 21 plus 16. And it's 65 over 28. And that's your answer. Let's make sure I didn't lose any constants along the way. I don't think I did. Nope, we're good. Okay then. Thanks for watching.